Hello dear children, in a previous class we discussed what is a measurement, what is the need of measurement and what is a physical quantity and how can we express the physical quantity, what is a unit and choice of unit which we discussed. Whereas in today's session we are going to discuss about types of units and a system of units, and after that we will be discussing about the units of length, mass, time in detail. So in today's class first we see what are the types of units. My name is Nanesh, welcome to our channel Physics Plaza. Children, what is a unit? A unit, it is a known standard quantity which is used to measure the physical quantity of same nature. So mainly here we will be having two types of units. Base units, it is also called fundamental units, and we will be having a derived units. First let us see what are fundamental units. Children, the units which do not depend on any other units are the units which are not derived from any other units are called actually fundamental units. Example, let us take a unit of length, that is a meter. You can see meter, children, meter. So these are the examples for fundamental units. Then what about derived units? Children, the name itself will give you the concept. Derived means they are derived from other units. So the units which are derived from other units means what? They are derived from fundamental units. As they are derived from fundamental units, which means what? They are depending on other units. So the units which depend on other units or which are derived from fundamental units are called derived units. So example, let us take the unit of area is a meter square. Unit of area is a meter square. So it is derived from meter. It is derived from meter. Even you can take a unit of volume. It is a meter cube. It is meter into meter, whereas it is meter into meter into meter. Which means what? So these are the units which are derived from the fundamental unit of meter. Fundamental unit of length is a meter. But now dear children, now let us see then how can we write the derived units. So many children, they are getting confused, and some students they will try to by heart the units. Children, if 1 or 2 or 5 up to 10 you can by heart, but there are many derived quantities are there. So it is not possible, it is highly impossible to by heart the derived units, and it is not at all correct to even by heart the units also. What units? Derived units. Then how? For that we have a methods, steps to write a derived units. Dear children, there are 4 steps which we have. If you follow the 4 steps, 100% you will get the correct derived unit. For that you no need to by heart. Now let us see what are the steps to write the derived units. First one, do the simplification. So children, these are the 4 steps in order to write the derived units in the proper way. Now let us see what is actually first one. So if you want to write derived unit for any physical quantity, first we have to write the formula of that physical quantity. Then the first one is write the formula of physical quantity. And after writing that what we can say formula of physical quantity, if all or what in that, for example, all fundamental quantities are involved, no problem at all. If not, what we have to do? We have to break, we have to split that formula in terms of FQ means what? Fundamental quantities. So once you will get the formula in terms of all fundamental quantities, let us substitute the what? Let us write the units of fundamental quantities, and finally we can do the simplification. The best example, let us see the children. Now let us see the one example in order to understand how to write the derived units. The best, first we will write to what? Density. We will try to write the units of density. So first step, what we have to do? We have to write the formula of density. Children, we know that density is equal to mass by volume. Mass by volume. So first step we have done with the first step. Now we have to check whether all quantities are fundamental quantities or not. If all quantities are fundamental quantities, no problem, directly you can write the units of fundamental quantities. If not, if any derived quantity is involved, that should be what the children splitted, we have to break down that into fundamental quantities. Here mass is a fundamental quantity, but volume is not fundamental quantity. So now what we have to do, volume should be written in terms of fundamental quantity. How can we write? There is a first step we have written. Second step, density is equal to, let it be, it is a mass only by. So volume can be written as, what we can write, length into breadth into height. Length into breadth into height. Now you can check, mass is a fundamental quantity. Your length, breadth and height, these all are nothing but lengths only. So now all fundamental quantities are involved. Now what we have to do? Third step, we have to write the units of these fundamental quantities. That is, unit of mass is what, you children? It is kg per, this length is meter, it is meter, it is meter. That is, meter into meter into meter is what? Meter cube. So finally we got it is a meter cube. So here kg per meter cube is the unit of density, So these are the four steps which we have to follow in order to write the derived unit. Now let us try to write the units of force, dear children. Force. So I want to write the units of force. So first step we have to write the formula. So here force is equal to, children, mass into acceleration. Here mass is a fundamental quantity, but acceleration is not fundamental quantity. So that should be, we have to break down the acceleration into fundamental quantities. So here mass means, let me write a symbol m, okay, or else mass we can write. So acceleration is nothing but what, children? It is a velocity by time. It is, here three quantities are there, in which mass and time are the fundamental quantities, but velocity is not a fundamental quantity. Again we have to break down that velocity into fundamental quantities. So it is, let me write this time here. So that is mass by time, So here velocity, how can we write it, children? Displacement by time. So velocity, now you can check. So mass is a fundamental quantity, displacement is nothing but length, fundamental quantity, time is a fundamental quantity. So finally we got force formula in terms of all fundamental quantities. That is, second step is over. Third step, what we have to do? Now write the units of the fundamental quantities which are involved. So let us write here. So what is the unit of mass? Kg into displacement is, meter, displacement is meter, and time is second. Second into second will be second square. So we can write it as a, that is second into second. So we can write as a kg meter per second square. So kg meter per second square is the unit of force. Of course, this we can call it as a Newton. This only we can call it as a Newton. So children, this is how actually we can write the derived units step by step. Children, I repeat once again, there are the four steps to be followed. First step, write the formula. Second one, break down the formula into fundamental quantities. Third step, write the units of fundamental quantities. And the fourth step, if it is required, do the simplification like this. Might be multiplication will be there, divide will be there, like taking a denominator into numerator. If you want to do, you can. This is very easy method to write the derived units. Please copy it. Now we will learn system of units. Dear children, in order to express the fundamental units, we have three system of units which we have. In that, one is MK system we have, and second one is CJ system which we have, third one is FPS system which we have. First one is MK system. Digitally here MK system is also called as metric system, whereas CJ system is also called as French system, whereas FPS system is also called as British system. It is. Dear children, in these systems you can see three letters will be there. First letter will represent length, second letter represents mass, third letter represents time. That is, it's the length, mass, it is time. So here in MK system, first letter represents M for meter. So in MK system, the unit of length is meter. Unit of length is meter. Whereas in MK system, K reference kilogram, that is a mass. Mass is measured in terms of kilogram, it is. Kilogram. Whereas time is measured in second. Time is measured in second. Time is as is the second only. So dear children, so these are the system of units which we have. But the thing is that dear children, so with the help of this system, we can measure the only 3 fundamental quantities, and moreover we can say that these system of units are outdated. So we are not using now. Now worldwide we are using SI system. We are using SI system. So International System of Units. It's very important. In SI system, dear children, how can we measure the mass? So here mass is measured in kg only, whereas length is measured in meter only, and time is measured in second only. Time is measured in second. Then you may get a one doubt. Sir, in MK system also we are measuring meter, kilogram, second, whereas in SI system also we are measuring. What makes the difference? Children, the SI system is a updated version of MK system. It is an extension of MK system. That is, in MK system we can measure the only 3 fundamental quantities, that is length, mass, time. But whereas dear children, in SI system we can measure not only these 3 quantities, and other than this, rest of the 4 fundamental quantities are there, right? So those also we can express in terms of SI system. So once again I am saying dear children, SI system is a updated version. It is a new version of the MK system. Now we will see what are the units of all fundamental quantities in SI system. So these are the fundamental quantities which we have and which we are going to measure in terms of SI units only. Dear children, length is measured in meter, whereas mass is measured in kilogram, time is measured in second, temperature is measured in Kelvin, and current is measured in ampere, amount of substance is measured in mole, luminous intensity is measured in candela, whereas angle and solid angle, these two are the supplementary quantities. So angle is measured in radian, whereas solid angle is measured in steradian. Now the symbols also very important. Children, meter symbol is M only, and kilogram symbol is kg. Small k you must write, it is not a capital K, small k only. So here also small k only. So these are the, so we can, and here also dear children, once again I am saying here, these 3 we can measure in MK system, but these all are we are measuring in a SI system, which means what here? So MK system is a part of SI system. So that's what we can see, that here SI system is the extension of MK system. It's a new version of the MK system. So these are the fundamental quantities and their units and their symbols. Children, if these things all are in your mind and you can play with the derived units, you can write any derived unit once you know, because finally we have to write derived unit in terms of fundamental quantities, and we have to substitute the symbols of the fundamental units in order to get the derived units. Just copy it. But children, so whenever we are using the numbers, sometimes we will be dealing with the very big numbers, at the same time we will be dealing very small numbers also. So writing such a big numbers and a small numbers, it may not be comfortable to us. So for that only we are going to use a prefix. For example, I will tell you, children, for example, so let us take a case of what we can say, let us take any mass of any virus, let us take any virus. So probably it's around, it will be 1 by billionth part of gram. The mass of any virus generally usually it is a 1 by billionth part. So that is, it will be 0.000001 gram it will be there. But writing such a small number like a 0.000, so it is not comfortable to us. So this can be written as, actually how can we write, 10 power minus 6 gram. Here this 10 power minus 6 only we can call it as a prefix. This only we can call it as a prefix. This only we can call it actually micro. This one we can call it the micro. Means to express very small numbers, at the same time very big numbers, we are going to use prefixes, so that it's a very comfortable to us to express any numerical values in a measurement chapter. In that children, let us see the most commonly used prefixes for bigger numbers. First we will see the for bigger numbers. So mainly there we will be using what we can say 10 power 3. So 10 power 3 is kilo. 10 power 3 is a kilo. Its symbol is K. 10 power 3 LT. Dear children, these are the most commonly used prefixes to express bigger numbers. To express actually bigger numbers. And similarly, we can use prefixes to express the very small numbers. Let us see, dear children. So here 10 power minus 1, it is deci. It is a deci copy. So this also we can write micro into micro. Can be written as even. We can be written as. So dear children, so these are the prefixes which we will use to measure the very smaller numbers. Whereas these are the prefixes which we use to measure the very big numbers. Okay, dear children, fine. Now we will discuss the units of length, units of mass, and units of time. Units of length. Dear children, in SI system, what are the units of length? Meters. Children, in SI system, the units of length are meters only. Now we will be discussing the subunits of the meter and as well as multiple units of meter also. Dear children, first we will see the subunits of meter. Subunits of meter here. Dear children, so when we want to express the very small numbers, and a meter is considered to be a very big number, there we cannot use a meter. So there actually subunits are very useful. So in this first one is centimeter. Centimeter. Children, centimeter is what actually? It is a 1/100th part of meter. 1/100th part of meter. This we can write as a 1/10 square meter, or we can write 10 power minus 2 meter. So in a shortcut we can write 1 centimeter is equal to 10 power minus 2 meter. And whereas the second one is millimeter. So children, it is 1/1000th part of meter. This only we can write as a 10 power minus 3 meters. So here 1 mm, that is 1 millimeter, is equal to 10 power minus 3 meter. It is a 1 centimeter is equal to, and it is 1 millimeter is equal to 10 power minus 3 meter. Whereas the fourth one is 1 micrometer is equal to micrometer. So it is a 1/millionth part, that is 1/0000 meters. So it will be 1/10 power 6 can be written as 10 power minus 6 meter. So that is 1 micrometer can be written as 10 power minus 6 meter. Whereas the fourth one will be using actually nanometer additions. Very important. Nanometer. So here nanometer is what actually? 1/billionth part of meter. 1/billionth part. How small it is, just imagine. 1/billionth part of meter. That is 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9 it will be. So this can be written as 1/10 power 9 meter, and it is also written as 10 power minus 9 meter. So 1 nanometer, that is we can write 1 nanometer is equal to 10 to the power of minus 9 meters. So children, these are the subunits of meter. These are the subunits of meter. And whereas multiple units of meter, dear children, multiple units of meter I am writing, multiple units of meter. Sometimes, dear children, when we want to measure the distances, like the distance between the districts, the distance between the villages, so there meter will become meter is considered to be very small. There we cannot use a meter. So there we will be using kilometer. So kilometer is a multiple unit of meter. So children, kilo means already is a prefix which we learned, this 1000. So it is 1000 meter. Or we can shortcut write 1 kilometer is equal to 10 to the power of 3 meters. 10 to the power of 3 meter. So children, these are the subunits of meter and these are the multiple units of meter. Now we will be discussing the non-metric units of meter. So now we will see non-metric units of meter. Dear children, so in our, of course, in a day-to-day life, in order to measure and for the measuring purpose of length and all this thing, we can go for centimeter, millimeter, even we can go for kilometer. But dear children, if you want to measure the distance between the celestial bodies, so there what will happen, kilometer is nothing, so there we cannot use. For that we are going to learn about a non-metric units of meter. In that the first one is astronomical unit, AU, we can say it as a astronomical unit. A shortcut we can add AU, astronomical unit. So what is the astronomical unit, dear children? If you can take, here is earth and here is sun. Dear children, the average distance between sun and earth is equal to the 1 astronomical unit, So here how astronomical unit is related to the meter. Children, it's very important. Children, here 1 astronomical unit is equal to 1.496 into 10 to the power of 11 meters. 1 AU is equal to 1.496 into 10 to the power of 11 meters. And the second non-metric unit which is used to measure the distance between even earth and other stars and distance among the stars. So their astronomical unit also will become very small. Very small means it will become very small only. So then we can go for actually light year. But dear children, the problem with this word is that there is a misconception. Generally, year means what? What do we think? Year means generally we use year for actually to represent the time. So that's what many children will get confused, and a light year means they will think that it is unit of time, but it is wrong. Children. Light year is a unit of length only. So usually it is used to measure the distance between earth and other stars actually. But how can we write the relation? How can we make a relation between light year to the meter? So for that we should understand what is a light year. Children, we know that light has some velocity. You can take even speed also. So what is the speed of the light, dear children? Can you guess what is the speed of the light? So we all know that light can travel 3 lakhs kilometers, that is 3 into 10 power 8 meter per second. So my question is that in 1 second it is traveling 3 into 10 to the power of 8 meter per second, meters, in meters. Whereas in 1 minute it is 3 into 10 to the power of 8 into 60 meters. Whereas in 1 hour it will travel 3 into 10 to the power of 8 into 60 meters. So this is a distance traveled with the light through vacuum in 1 hour. What about 1 day it is? So in 1 day, dear children, it can travel this much distance, these many meters. Then what about in 1 year? Do the multiplication with 365. So here 1 year. In 1 year, dear children, in 1 year it is 3 into 10 to the power of 8 into 60 into 24 into approximately we will take it as a 365. So dear children, this is the distance traveled. This is the distance traveled by the light in 1 year through the vacuum. So this distance only is equivalent to the light year. So if you can do the simplification, you will get it as a 9.46 into 10 to the power of 15 meters. So children, this is what actually light year. So light year is equal to 9.46 into 10 to the power of 15 meters. So what is the light year, dear children? The distance traveled by the light in 1 year through the vacuum is called actually light year. And dear children, so even other than this light year also, we have one more non-metric unit of meter, which is used to measure the very much bigger, what we can say, distances. We can say that is parsec. That is actually parsec. So mathematically, dear children, 1 parsec is equal to 3.26 light years. Ly we can use a symbol to represent the light year. So dear children, these are the non-metric units of meters which are used to measure, which are used to measure the very long distances. We can say that the distance among the celestial bodies. But dear children, can we use these units in order to measure the, even for example, radius of the atom, radius of the nucleus? There it is too much it will become. So there again we have another units to measure the distance, even radius of the atom and radius of the nucleus. Now let us see that. So children, till now we discussed about actually astronomical unit, light year and even parsec also. So those are the units which are used to measure actually very big distances, very long distances. They are not useful, I can say that, to measure the radius of the atom, radius of the nucleus. For that only, in order to measure the very small distances, very much small distances, even we can use, we can say actually scientific purpose we will use. That is actually angstrom. The first one is, dear children, it is a angstrom. So mathematically, dear children, 1 angstrom is equal to 10 to the power of minus 8 centimeters. 10 to the power of minus 8 centimeters. But we know that 1 centimeter is equal to 10 to the power of minus 2 meters. 1 centimeter is equal to 10 to the power of minus 2 meter. This you can substitute here. So here it will be 10 to the power of minus 8 into 10 to the power of minus 2 meters. So as bases are same, power should be added. So this will become 10 to the power of minus 10 meters. So here 1 angstrom is equal to 10 to the power of minus 10 meters, or 1 angstrom is equal to 10 to the power of minus 8 centimeters. But children, this angstrom unit also became outdated. Nowadays we are not using angstrom, rather we are using nanometer. So we need to understand how angstrom is related to the nanometer. Children, it's very important. So from this only we can make a relation between angstrom and a nanometer. Children, here 1 angstrom is equal to this, can you write like this, 10 power minus 1, okay, into 10 to the power of minus 9 meters. Of course, we can write. But this 10 power minus 1 can be written as 1 by 10. Yes, we can write as a 1 by 10. But 10 power minus 9 is what? It's a prefix which we learned already. So 10 power minus 9 is nano. So this we can write as a nanometer. So here 1 angstrom is equal to 1 by 10 nanometer. If you want to write nanometer as a subject, get this step this side. So what do you get here? 1 nanometer is equal to 10 angstroms. Children, it's a very important relation. Very means very much important relation. So this is what actually angstrom. Usually angstrom is used to measure the radius of the atom, but nowadays we are using actually nanometer. So 1 nanometer is equal to 10 angstrom. It's a very important. Dear children, other than angstrom, even if you want to measure the radius of the nuclei, so this is not enough. It will become very much bigger unit to measure the radius of the nucleus. For that, we will use Fermi. So Fermi is a unit usually which is used to measure the radius of the nucleus. Children, 1 Fermi is equal to 10 to the power of minus 15 meters. 1 Fermi is equal to 10 to the power of minus 15 meters. So children, so these are the units of length. We discussed there subunits of meter, multiple units of meter, and then we discussed even non-metric units of meter. There we discussed even for bigger units, bigger what we can say long distances, even for a very small. Dear children, angstrom, that is nowadays we are using much actually nanometer only, nanometer and a Fermi. So we will use in order to express, in order to measure the very small what we can say lengths, we can say that, and it's subatomic particles will be there like electron, proton, neutron. So in order to measure the atom, what we can say radius of those particles, we'll be using actually angstrom, nanometer and Fermi. Okay, dear children, just copy it. Now we will learn the units of mass. We'll see the units of mass. In SI system, we have it is kg, that is kilogram. That is a kilogram. But every time we cannot use a kilogram. Sometimes we need to measure the very huge amount of mass, and sometimes we need to measure very small amounts of mass. So there always we cannot use a kg. So for that only, let us see actually. First we learn subunits of kg. Subunits of kg. So children, in order to measure very small measurement, children, when you go to the gold shop, for example, there can you buy like a gold in terms of kg? It's not that. If you go to gold shop and ask, just I want a 10 kg gold or 15 kg gold, immediately the shop person will call to the police and they'll come and they'll start inquiry. So who are you and from where are you getting money to buy 20 kgs and all these things will be there. So there we cannot use actual kg. So very small. Even gold can be measured in even grams, milligrams also. Okay children, now let us see. So under these sub units of kg, dear children, the first which we will learning is a gram. First one we will be learning is a gram. Children, gram is actually 1/1000th part of kg. 1/1000th part of kg. So this we can write it as a 10 power minus 3 kg. 10 power minus 3 kg. So 1 gram is equal to 10 to the power of minus 3 kg. And the second one which we will be using even milligram also. So this is a milligram. So milligram is what actually 1/millionth part. 1/millionth part of kg. That is 1, 2, 3, 4, 5, 6 kg it is. So this can be written as 10 power minus 6 kg. So these are the two subunits of kg. Now we will use multiple units kg. So dear children, even when we go to the market, not like a vegetable market, like a mirchi yard, a cotton yard will be there. There you cannot take actually cotton, mirchi and during like import and export purpose. There we cannot measure kgs. There we will be measuring in terms of actually quintal only we will be measuring. So dear children, 1 quintal. So here quintal, 1 quintal is equal to 100 kg. So quintal is a multiple unit of kg. First one which we will be learning. Then second is metric ton will be there. Metric ton. So metric ton. So addition 1 metric ton is equal to 10 quintals. Metric ton is equal to 10 quintal. So as 1 quintal is equal to 100 kg, 10 into 100 will become 1000 kg. So here 1 metric ton is equal to 1000 kg. 1000 kg. So dear children, so these are the subunits and multiple units of kg, and which we will use in a daily, what we can see in our day-to-day life we can use. But dear children, other than this, we will be having even non-metric units of kg also. It's a very important. Dear children, non-metric units actually usually we don't use in our daily routine purpose. Those will be used, we can say that even mainly research purpose, in order to a laboratory, scientific purpose we can use that. See, non-metric units of kg. Additionally, if you want to deal the subatomic particles, for example, if you want to measure the what we can say mass of the proton, mass of the neutron, can we measure in kg? So it is not that we can't measure, because it is a very tiny, even it can't be seen also, such a very small one. So there actually kg is not at all suitable to use. Kg might be a unit of mass, but we cannot use it as to measure the even mass of the subatomic particles. There we will be using actually AMU. So what is AMU, dear children? Atomic mass unit. Atomic mass unit. But how to understand what is atomic mass unit? Dear children, atomic mass unit is what we define in terms of carbon atom. So let us take a neutral carbon C612 atom. C612 atom. Okay, so just you take a 1 atom of carbon. 1 atom of carbon you can take. That 1 atom of carbon has some mass, right? For example, dear children, let us say this is, children, for sake of our convenience I am saying, let us say it is a mass, children, it is a mass of 1 carbon, it is a mass of C612, mass of C612. Now what we will do, this mass is there, right? So this mass, let us divide into 1, 2, 3. Now here 1, 2, 3. Now how many parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 parts we divided. So try to understand. So this whole one, this entire one is mass of 1 carbon atom, that is C612. It is the mass of C612. We divided into 12 equal parts. 12 equal parts. Dear children, now in this, each equal part, it has some mass, right? Each equal part, the mass of this each part only we can call it as a AMU. Only we can call it as a AMU, which means what, children? 1/12th part of mass of carbon atom. So children, here 1 AMU is equal to 1/12th part. 1/12 12th of mass of C612. So C612, it has some mass. That mass is divided into 12 equal parts. Each equal part is equivalent to the 1 AMU, atomic mass unit. How can we relate AMU in terms of actually kg? Children, here 1 AMU is equal to 1.66 into 10 to the power of minus 27 kg. So means 1 AMU is nothing but equivalent to the mass of the proton. Children, 1.66 into 10 power minus 27 kg is what actually? It is equivalent to the mass of the proton. Means AMU is equivalent to the mass of the proton. Children, AMU is used to measure the mass of the subatomic particles. Okay, it is fine. But whereas when we want to measure the mass of the celestial bodies, dear children, for example, celestial bodies is very huge. There we can't use actually, quintal, metric ton, we can't use actually. There we have one special unit that is called solar mass. That is what actually? Solar mass. Dear children, solar mass is a unit. It is a unit of mass only, which is used to measure the mass of the celestial bodies. So, one solar mass is equal to, children, it is 2 into 10 power 30 kg. 2 into 10 power 30 kg. Now you can imagine how big the unit of solar mass is. So beside 2 you have to keep a 30 zeros. So those many kgs. So children, AMU is used to measure the mass of the subatomic particles usually, and whereas solar mass is a unit of mass only, which is used to measure the mass of the celestial bodies. So these are the actually non-metric units. So now we will see the unit of time. Children, in all systems the unit of time is same, that is second only. So in SI system the unit of time is a second. Dear children, what is the second here? So if you want to know the second, so you should know what is a mean solar day. Children, we all know that Earth is rotating about its own axis. Further it will take time. The time taken by the Earth to complete one rotation about its own axis of rotation is called mean solar day. Children, one mean solar day is equal to 86,400 seconds. Then 1 second is equal to, what can we write? 1 second is equal to 1 by 86,400 mean solar day. Children, here MSD, it is MSD. So MSD means, don't think it is a Mahendra Singh Dhoni, one of the legendary cricketer and one of the best Indian cricket captains actually. But here MSD means not a Mahendra Singh Dhoni. It is MSD means what actually is a mean solar day. So how can we define second day, children? 1 by 86,400th part of mean solar day is called actually is equivalent to the 1 second. Dear children, then what are the very smaller units of I can say that subunits of second, smaller units, subunits of second it is. So we have millisecond. So millisecond. Children, millisecond is what? 1 by 1000th part. That is 1 by 1000th second. 1 by 1000 second. This one we can write 10 power minus 3 second. And the symbol we can use 1 ms is equal to 10 power minus 3 second. And other than this, even we have microsecond. It is microsecond. Microsecond is 1 by millionth part. 3, 4, 5, 6 seconds. So it can be written as 10 power minus 6 seconds. The symbol can be microsecond is equal to 10 power minus 6 seconds. But dear children, what is the smallest unit of time? It's very important. Smallest unit of time is shake. It is a shake. So shake is equal to 10 to the power of minus 8 seconds. 10 to the power of minus 8. It's very important. The smallest unit of time. Here you may get a one doubt. Sir, here 10 power minus 6 is there and even nanosecond 10 power minus 9 is there. But how shake can be a smaller? Children, 10 power minus it is a nanosecond. Nano is what actually is a prefix. It is not a unit. It is a just prefix only. But here shake is smallest unit of time, which is equal to 10 power minus 8 seconds. Now we will see the bigger units of time. So children, these are the bigger units of time here. So usually we know that is a minute equal to 60 seconds. and 1 hour is equal to 3600 seconds, and this is very important examination point of view. 1 day is equal to 86,400 seconds. Actually, this 1 year is very important. So 1 year is equal to 3.15 into 10 to the power of 7 seconds. Decade is equal to 10 years. So you can multiply with this with a 10, you will get 3.15 into 10 power 8 seconds. So century is equal to the 100 years, which is equal to 3.15 into 10 power 9 seconds. And finally, it is a millennium, which is equal to 1000 years, which is equal to 3.15 into 10 power 10 seconds. So children, these are the bigger units of time. Now, so in this unit, dear children, the last very important topic is that guidelines, means how to write the units. So here what happens is that whenever we are writing a unit, sometimes we will be doing some small wrong things. For that only we will be losing a mark. Especially, dear children, when we are doing a numerical at the end. Whereas in a mathematics, after getting an answer, you don't need to think anything. But whereas in a physics, dear children, after getting an answer in numerical, you need to think about the unit. Sometimes we know the unit, we will write, but little bit thing will go wrong. So due to which what will happen, we may lose 1 mark at least there. So now we are going to discuss how to write the units in a perfect way. What are the rules to write the units? After scientist it is. Children, look at here. So just children, here one very important thing which we have to notice. So sometimes what will we do, actually what we do, we know that many persons, they have done a great contribution towards the science and technology. So to remember those scientists, actually their contribution and their hard work towards science and technology, we'll be taking their names as a unit. So this is a point very important where we have to concentrate. So here units, in a simple term, based on that names, we can make into 2 categories. The units which are named after the scientist and the units which are not named after the scientist. So how we can write these units, how we can follow these 2 rules, so very important. For example, dear children, let me tell you. For example, when we want to write the full name of the unit, either it is named like after scientist or not, whatever it may be. For suppose, dear children, what is a unit of work? Children, so the unit of work is, we know that it is a joule. So here some children, they will write like this, Joule, fine. And what about the unit of length, dear children? So in a length, the S unit of length is meter. Some children will write like this. So your thing is that actually these 2 are wrong. So whether the unit which is named after scientist or not, whatever it may be, when you want to write the full name of the unit, dear children, first letter must be small. So here, what is the correct here? Joule, it is a correct. So here you can write, here it is metre, it can be right. So whether it is a scientist name or not, whenever we want to write the full name of the unit, first letter must be small. It is the first rule. In this, it is the first rule. In this, the second thing is that, children, every time we cannot write the full name of the unit. Sometimes we will be using symbols. So sometimes what will happen, for symbols, let us take for this only. Some children will take a symbol like this. They will take a small j. So it is wrong. As it is a scientist name, dear children, you are using a scientist name as a unit. So when you want to write the symbol of that unit, actually, can go for a capital letter, can be used. But here, writing a small m symbol, dear children, is very important. So symbol, small m is correct. You cannot use a capital M here. Your capital M will be wrong actually. Because here capital M means it may be like a mega, which we learned in the prefix. So if we can use a capital M as a symbol, again there will be some confusion between the unit of length, at the same time the prefix called mega also. So here the important thing which we have to notice is that when you want to write the symbol of a unit, if it is a scientist name, if it is taken after the scientist, then go for a capital letter. If it is not a scientist name, then go for a small letter. So this is the first rule which we have to understand. Now let us see the second rule. Unit. So dear children, compound unit can be formed with 2 or more units, the combination of 2 or more units. So it might be like multiplication or divide. Let us see, dear children. For example, let us take the unit of work only. Let us take, dear children. So here we know that it is work. So work is equal to force into displacement. We know that force into displacement. So force is measured in a Newton, displacement is measured in Newton and displacement measured in meter. So it can be Newton meter. So if you want to write a Newton meter, dear children, here you can write dash, is not a minus, Newton meter, or it can be written as even Newton dot meter also. Means this multiplication symbol can be accepted. Okay. Whereas if that compound unit is formed with a what we can say divide, like one unit is divided with another unit, sometimes it is also possible. So let us take a example of, like can take a unit of, let us take a density. So unit of a density, children, here you know density is equal to, we know that is a mass by volume, it is mass by volume. So mass is it is a kg and volume is meter cube. So this meter cube can be taken to the numerator, then it will become kg 10 power m power minus 3, which means what actually here negative powers are accepted, negative powers can be written. So these are the two things which we should be very careful whenever we are making a compound unit. Compound unit, how it is formed? By multiplying with one unit with another unit, or by dividing one unit with another unit, we will get a compound units. So if it is a multiplication, children, so dot can be accepted, or this dash also can be accepted. And here if it is like with a divide, it is like with a, because of divided by then what will happen here, negative powers also accepted. So this is a second rule which we need to understand. Now let us see the third rule it is. And the third one, dear children, to avoid powers of a tens, actually we will use, generally we will be using the prefix, but here one very important thing is that you cannot use more than one prefix. For example, it is there like this, 1 2 3 4 5 6 7 8 9, let us take something, what we can say, what it is there. But some children, this actually this can be written as 1 2 3 into 1 2 3 4 5 6, we can actually, okay children. So this can be written as 10 power 3 and this can be written as 10 power 6 watt. But we know that 10 power 3 is a kilo, 10 power 6 is a mega, so you cannot write kilo mega watt. It is wrong because it is a one prefix, it is a one more prefix. So two prefixes cannot be used. So directly this can be written as 10 power 9 watt. So 10 power 9 is what actually? So it is a gigawatt you can write. So it's very important. So whenever we are using prefixes in the place of actually powers of 10, you must be very careful. So you should use only one prefix. You cannot use more than one prefix. Fine. And the fourth one is that, children, when prefix is used with the symbol of a unit, and the prefix and the symbol combined becomes a unit. It's very important. For suppose something or length or some value is given, it is written like this. So 10 power 3 meters whole cube is there. Whole cube is there. So some children, how they will write, they will write like this. 10 power 3 meter cube they will take. It is wrong. It is wrong because this together will become actual unit. This combination together will become a unit. So this we should write as a 10 power 6 meter cube. So this is right. It's very important. So whenever there is a combine, if you are using prefix with a symbol, so that combination, the combination we should take as a unit. So the power is applicable for this prefix and as well as the symbol of that unit also. And one more very important thing is that here this is most of the children, they will be commonly doing a mistake is that actually whenever we are writing a units, you cannot use a plurals. You cannot use a plural form. For example, dear children, so you can say that the distance between, for example, my house and the kirana shop is 10 meters. Let us say 10 meters. So here 10 meters means how should I write actually? Some children will write 10 meters, they will write like this. MS also they will write. You cannot write here like this. Why? MS, it can be, it is a millisecond, complete the since the meaning only will change. So you cannot write a 10 meters like this. So simply we can write the 10 meters only. So here plural forms are not accepted. Okay children, so these are the actually rules to write the units actually. Okay children, and in this session what we have discussed, just once again let us recall. So here we discussed actually the types of units, fundamental units and derived units we discussed, and the system of units, and after that we discussed about units of length, units of mass and units of time, and finally the guidelines for writing the units. Thank you so much, all the very best.